LWO1 WeatherNet. Liftoff conditions looking pretty good.
TS is ready for launch.
Ignition. Liftoff.
Falcon 9 has cleared the tower.
Ten, 9, 8,
Side booster ignition.
6, 5, 4, 3, 2, 1.
Good afternoon. It's Wednesday, May 26th, and on screen is a live view of Falcon 9 as it awaits its 2:59 p.m. Eastern Time launch from Space Launch Complex 40 at Cape Canaveral Space Force Station. My name is Yomezo, a Dragon propulsion engineer, joining you from our headquarters in Hawthorne, California. You're watching a live webcast for the 13th Starlink launch this year and 29th to date. Starlink is a satellite internet constellation designed and manufactured by SpaceX that can provide high-speed, low-latency internet to people living in remote and rural locations around the globe. If you've been following Starlink's progress, you'll know that our Starlink beta service is now available in the United States, Canada, New Zealand, Australia, and several locations around Europe. We're excited to announce that service is now also available in Belgium and the Netherlands. To date, over 500,000 people have placed an order or put down a deposit for Starlink, and with every launch, we get closer to connecting more people across the world. As we launch more satellites, install more ground stations, and continue to improve our networking software, our data speed, latency, and uptime will improve dramatically. In addition to being able to provide our customers with better service, with every Starlink launch, we get closer to our goal of near global coverage of the populated world. As always, head over to starlink.com to learn more. We are now at T-minus 11.5 minutes, and all systems are still go for an on-time liftoff at 2:59 p.m. Eastern Time. With that, let's take a closer look at the rocket that you see on your screen.
Hello, I'm Shiva Bharadwaj, a space operations engineer. Now the Falcon 9 on your screen, that's our two-stage liquid-fueled rocket, has been loading propellants since T-minus 35 minutes. Falcon 9 stands 229 feet tall. That's slightly taller than a 21-story building. And much different from our recent Starlink missions, which launched and landed boosters for an 8th, 9th, and even a record-breaking 10th time. The booster that we're flying today is fairly new, having only supported the Sentinel-6A mission last year. Now, the bottom two-thirds of the vehicle is the first stage. You can see some of the soot left over from its previous flight. The first stage accelerates the vehicle through the Earth's atmosphere into space with the help of 9 Merlin engines that it has at its base. As I mentioned, we will be attempting to recover this first stage for the second time on our drone ship named Just Read the Instructions. On top of the first stage, we have our black carbon fiber inner stage, and on top of that is Falcon 9's second stage, which has a single Merlin vacuum or MVAC engine. Once the first and second stages separate, about 2.5 minutes into the mission, the Merlin vacuum engine will ignite and carry our 60 Starlink satellites into an elliptical orbit around planet Earth. Now, you'll also notice this large nose cone at the top of the rocket. That's called a fairing. That's where the stack of Starlink satellites is safely enclosed. The fairing's job is to protect those satellites from aerothermal heating, aerodynamic loads, and contamination during the ascent phase. Once we reach the vacuum of space, we'll jettison those fairing halves as the second stage continues on its journey to orbit. The fairing halves protecting our Starlink payload have quite a history. This will be the first fifth flight for one of the halves. Before today's launch, that half supported 4 previous Starlink missions going back to 2019. The other fairing half will be flying for the third time, previously having supported the Transporter 1 and Starlink 21 missions. Now, today's flight also marks the 40th time SpaceX has reflown fairing halves since November 2019. And of course, we're going to be attempting to recover them today using our recovery vessels named Go Searcher and Go Navigator. Beautiful day at the Cape. Weather is forecast 90% favorable for liftoff, and the recovery conditions look quite good for the booster. So with that, the vehicle, satellites, weather, and range are all looking good for an on-time liftoff just a few minutes from now. Now, for some reason we do not launch today, we do have a backup opportunity available tomorrow at 2:38 p.m. Eastern Time.
Now that you know a little about the structure of Falcon 9 and its engines, the propellant, which is a substance used to create the energy to make the rocket go. Falcon 9 is a bipropellant vehicle, meaning it uses two propellants, a fuel and an oxidizer. An oxidizer is a type of chemical which a fuel requires to burn. Most burning on Earth uses oxygen, which is prevalent in the atmosphere. However, in space, there's no atmosphere to provide oxygen or other oxidizers, so rockets need to carry them up on their own. For Falcon 9, our fuel is a refined form of kerosene known as RP1, and our oxidizer is a super chilled liquid oxygen called LOX. The liquid oxygen is chilled well below its boiling point so that it becomes what we call densified, which means there is a much greater amount of mass per volume, and we can load more of it into the booster. In addition to its propellants, Falcon 9 also needs an ignition source in order to go. And for that, we use the chemical TTEB, or triethyl aluminum and triethyl borane. When it is fully fueled, Falcon 9 holds just over 1 million pounds of propellant that the vehicle will burn through in less than 3 minutes after liftoff. Once our Merlin engines begin to burn RP1 kerosene and liquid oxygen, you'll see the rocket throwing the exhaust out of the engine bells in one direction while pushing the rocket in the other. This is a great example of Newton's third law of motion. For every action, there is an equal and opposite reaction. That million-pound weight of propellant is turned into all the flames that you see in flight coming out of the engines, creating the almost 2 million pounds of force exerted on the rocket to lift it up.
Now, in order to get to space, the rocket has to do more than just go up. It also has to go sideways really, really fast. At liftoff, gravity is pulling straight down on the rocket. But as we ascend, we'll start to tilt the engines, which is technically referred to as gimbaling. That turns the rocket horizontally. We're still going up, but we're also now heading horizontally away from the launch pad, and that maneuver is referred to as a gravity turn. The rocket typically needs to get to about 7.5 kilometers per second, or about 17,500 miles an hour horizontally, in order to avoid being pulled back down to Earth and to get into orbit. To help demonstrate the concept, imagine we were firing a cannon from a really high mountain. The cannonball will arc, and then gravity will pull it back down to Earth. As you increase the power, the cannonball will arc and land further and further away. Eventually, you could continue to increase the power, and the cannonball will go so fast that it ends up in free fall around the Earth. Gravity's still pulling on it, but it's going so fast that it never hits the ground. This arc that constantly misses the Earth is what we call an orbit. So when we get to liftoff today, keep an eye out on the orientation of Falcon 9. You'll see it initially start to go straight up until about T+10 seconds, at which point we'll start to shift orientation so Falcon 9 can start picking up sideways velocity. But before we get to that, why don't we check in on the status of the vehicle for today's launch?
We are currently just under T-minus 5 minutes and 30 seconds from liftoff, and Falcon 9 is now moving into the final stages of the countdown. We are currently waiting for the transporter erector, or TE, to retract, and that's that truss structure right next to the vehicle. First, the TE clamps will open, and the transporter erector will then begin to retract away from the rocket slightly, and at T0, hydraulics will pull the TE farther away from Falcon 9 as it lifts off. Now, the TE provides liquids, gases, electrical connections to the second stage, as well as air conditioning to the payload fairing.
Tanks pressing for strong back retract.
Now, those clamp arms that you can see just below the fairing should start to open soon, and strong back retraction should happen in just a few seconds here.
Strong back lever started.
You heard strong back has started to retract. You can see those clamp arms opening around the Falcon's second stage there. You can see that Stromback TE is started to move away from the vehicle there. Now, the first and second stages are both nearly fully loaded with 1 million pounds of kerosene fuel and liquid oxygen. Super chilled liquid oxygen is our propellant oxidizer, and that is what you see creating those white clouds that you can see around Falcon 9 there. And that's because the warm, humid ambient air causes the liquid oxygen to turn into a gas around the booster. Now, first stage should finish prop loading at T-minus 3 minutes, just under 10 seconds here. And the second stage will finish prop loading about a minute after that at T-minus 2 minutes.
Poco bleed.
At T-minus 60 seconds, Falcon
Stage
9...
1 locks load, closed out.
Falcon 9 will be in startup, and you heard that call out for stage 1 locks load complete. And when Falcon 9 gets in startup at T-minus 60 seconds, this means that the rocket's autonomous internal flight computers have taken control of the launch countdown. And just inside of T-minus 2 seconds, we light the Merlin 1D engines using that T-type ignition source we talked about, and we're set to lift off. The Starlink payload continues to be healthy, and the Falcon 9 team is tracking no issues on the rocket. Weather is still looking favorable, and the range is green for launch. So here at just over T-minus 2 minutes, let's listen in on the terminal countdown.
Stage 2 locks load, closed out.
We have just finished loading our second stage. Our Falcon 9 is now fully loaded with over 1 million pounds of kerosene, RP1, and liquid oxygen. Again, that white cloud coming from the booster there towards the middle is normal and expected. That is venting from the TE LOX line. Again, at T-minus 1 minute, Falcon 9 will go into startup, and this is when stage 1 and stage 2 will begin pressurizing for launch, and the flight computer will have taken control of the countdown.
Falcon 9 is in startup.
Falcon 9 is in startup, and in just a few seconds, the launch director should give the final go for launch.
Stage 2, pressing for flight.
Falcon 9, Starlink LDs go for launch.
You heard that call out for go for launch. All systems are go.
T-minus 30 seconds.
Let's listen in to the terminal count and watch as Falcon 9 takes our Starlink satellites to orbit.
T-minus 15 seconds.
Stage 1, pressing for flight.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition and liftoff.
Vehicle is pitching downrange.
Stage 1 propulsion is nominal.
What a beautiful day for a rocket launch here. As you can see, Falcon 9 has successfully lifted off from Pad 40 at Cape Canaveral Space Force Station, carrying our stack of 60 Starlink satellites to orbit. Moments ago, we throttled the engines down in preparation for max Q, or the maximum aerodynamic pressure that the rocket
Vehicle
will
is
see.
supersonic.
Vehicle is supersonic, and we should be passing through max Q here in just a few seconds.
Vehicle has reached maximum aerodynamic pressure.
We just passed through max Q, and in about a minute, we will have 3 events happening back to back, and that's main engine cutoff, or MECO, stage separation, and second engine start 1. So first, main engine cutoff. That is where all 9 Merlin 1D engines that you can see burning right now will shut off to slow the vehicle down in preparation for stage separation. And this is where the first stage separates from the second
Again, the
stage,
chill has begun.
with the first stage making its way back to land on our drone ship. Just read the instructions, while second stage continues on its journey to its third event, which is second engine startup 1. Now this is where the 1 MVAC engine on our second stage lights up and propels that second stage along with our Starlink satellites to orbit. What a beautiful view of those 9 M1D engines burning there on beautiful clear day. And we're coming up on main engine cutoff shortly here in just about 10 seconds.
MECO.
Stage separation confirmed.
And recognition.
You can see in that beautiful footage that we did just have MECO, stage separation, and second engine startup 1. Those grid fins are coming out on the first stage there on the left. And in just a few seconds, we should have our fairing deploy.
Fairing separation confirmed.
You heard the call out, and you can see on your video there that we have had successful fairing deploy. And again, today's flight marked the 40th time that SpaceX has reflown a Falcon fairing half since November of 2019. Now, this is also our first 5th reflight for one of our fairing halves and a 3rd for the other half. In order to recover these fairing halves for future flights, we will be attempting to recover them again with the help of our recovery vessels, Go Searcher and Go Navigator.
Stage 2 continuing towards its first orbit on the right-hand side of your screen. Left-hand side of your screen, you can see Falcon 9's first stage reorienting itself for its next 2 activities. That'll be 2 burns to come back safely to Earth. First of those being the entry burn. That's where we'll ignite 3 of the Merlin 1D engines to help slow down the first stage as it re-enters the upper parts of the Earth's atmosphere. The second burn will happen closer to the drone ship. That's the landing burn. That's where we'll ignite just the single center Merlin engine. That'll bring the first stage's velocity rapidly down to 0 for a soft touchdown. On the right-hand side of your screen, second stage continuing to burn nominally, acceleration right down the middle. And you can see the glow of the nozzle there. Now, if you are just catching up with us, we did have a
Stage 2 on nominal trajectory.
We did have a successful launch of Falcon 9 from Cape Canaveral Space Force Station. And first stage on the left-hand side of your screen is headed back to our drone ship named Just Read the Instructions, stationed out in the Atlantic Ocean. Second stage heading on the right-hand side of your screen is headed to its first orbit. As a reminder, today's mission does mark the 2nd flight for this booster. If you happen to catch fairing separation earlier, this will be the first 5th flight for one of those fairing halves and the 3rd flight for the other half. Reusability is critical to what we do here at SpaceX. It allows us to refly the most expensive parts of the rocket, and that drives down the cost. Now you can see the grid fins extended on the left-hand side of your screen. Every so often, you'll see puffs of white gas. That's attitude control coming from the first stage to help reorient us to get the 9 Merlins on Falcon 9 pointed towards the Earth. Those Merlin engines are optimized for thrust at sea level. They help Falcon 9 achieve about 190,000 pounds of thrust during ascent and descent. Meanwhile, the Merlin vacuum is optimized for space. That's why it has that larger nozzle. Now, coming up here is entry burn. Keep an eye out on the left-hand side of your screen.
Stage 1 entry burn startup.
Stage 1 FTS is safe.
This burn expected to last about 20 seconds.
Stage 1 entry burn shutdown.
And successful shutdown of those 3 Merlin engines. Now, if you followed along our missions in the past, you'll know that soot
Stage
on
2
the first
continues on
stage
nominal trajectory.
is an indication that the rocket has flown before. That's because we use rocket-grade kerosene, or RP1, as our fuel in Falcon 9. That's a carbon-based propellant. As we burn it, it generates soot. So with the engines down, as we're coming in through the Earth's atmosphere, the soot from the plume comes back up on the first stage and deposits it along the surface of the vehicle. Now, if we didn't do that entry burn, the first stage would come in very quickly in the atmosphere, and the aerodynamic forces could
Stage
cause
1
it to
is
rip apart.
transonic.
So that's why we do that entry burn. And we did temporarily lose the video feed, but we'll hopefully, there we go. Beautiful view. Now, at this point, since we're in the Earth's atmosphere, those grid fins will take over orientation and trajectory back towards the drone ship. Now, coming up, stage 1 landing burn will begin. Shortly after landing burn ends,
Landing burn startup.
the second stage's engine will shut down. We should be in our expected orbit there. So keep an eye out, see if we can get a video feedback for the first stage.
Stage 1 landing leg deploy.
Fantastic, right down the middle. That's our 85th successful recovery, 100th, 18th successful launch of the Falcon 9. Now keep an ear out here for second engine cutoff number 1 on the second stage. And with that, navigation officer, we did hear the call out there for SECO. Navigation officer will be checking
Expected loss of signal.
the
Cape.
parameters. Make sure we are in our intended orbit.
Nominal orbit insertion.
Fantastic news. So from here, we do have a coast phase followed up by the second burn of our second stage engine. These additional burns allow us to modify the orbits of the payload more efficiently than if we were to launch directly into our final orbit. That's just one of those quirks of orbital mechanics. And today, our second stage will coast for 35 minutes until we reach apogee, which is the highest point of the orbit. Views here on your screen of the fairing and then the Merlin vacuum engine on the second stage. So once we reach the highest point of the orbit, we will reignite the second stage for a short burn. And you can follow along the progress of the second stage with this animation showing where we are around the Earth. We'll be back here at T plus 44 minutes and 30 seconds for second engine start number 2. See you soon.
Acquisition of signal, Newfoundland. Expected loss of signal, Bermuda. Expected loss of signal, Newfoundland. Acquisition of signal, Goonhilly. Expected loss of signal, Goon Hilly. Acquisition of signal, Diego Garcia.
INVAC engine chill has begun.
Welcome back to the live webcast of SpaceX's 29th Starlink mission. We had an on-time liftoff at 2:59 p.m. Eastern Time from Slick 40 at Cape Canaveral Space Force Station. Second stage continues to look good, and our second engine startup 2 is just a few moments away here at T plus 45 minutes and 30 seconds. Now this will be a very short burn, only 1.58 seconds of our MVAC engine that you can see on your screen there, and this will help us get into a more circular orbit for our Starlink deploy. Hopefully we can catch that really quick burn on video. Now before this small burn, we have been pulsing the settling thrusters on our stage 2 to keep the propellant at the bottom of the tanks, ready to be pulled into the engine pump when it spins up here in just a few seconds. Again, we're just waiting for acquisition of signal from our ground station.
S2 burn 2 complete.
Good burn. Looks like the video came back just in time for us to see that burn there. And now we're just looking for a confirmation of a good orbit.
Nominal orbit insertion.
You heard the call out for the nominal orbit. We have another coast phase coming up here before we deploy our next batch of Starlink satellites into orbit. During this time, the spacecraft will start to spin along its central axis, giving the Starlink satellites the momentum they need to space themselves out over time after they deploy. We'll see you back here at around T plus 1 hour and 2 minutes.
Expected loss of signal, Diego Garcia. Acquisition of signal, Tasmania.
And welcome back to our broadcast for our 29th Starlink mission. If you're just joining us, we had a successful liftoff from Cape Canaveral Space Force Station at 2:59 p.m. Eastern Time, then successful stage separation, recovered our first stage for the second time on our drone ship named Just Read the Instructions, and had 2 successful second stage Merlin vacuum engine startups. So we had some video shots there of the second stage. We're awaiting our next major event, which will be payload deployment of the Starlink satellites. Now, over the last coast phase, we've started to spin the second stage a little bit. You can actually see maybe the sun might pop into frame there. And that's to help those Starlink satellites space themselves out after payload deployment. And here's a shot of the top of the second stage, camera looking up at the Starlink satellites. So coming up, payload deployment.
Starlink, deploy confirmed.
So that's confirmation of payload deployment. You saw the mechanism separating away, and now the Starlink satellites starting to make their way away from the second stage. Shortly, they will deploy their solar array. Wow, that's a beautiful shot of Earthrise in the background. But shortly, they will deploy their solar array, and then over the next few days and weeks, they'll start to distance themselves out. They've got onboard ion thrusters, and that'll help them make their way into their final operational orbit.
And with that successful deployment of our satellites, we'll bring today's webcast to a close. Thank you to the Range and Federal Aviation Administration for supporting today's mission. And of course, thank you to all of our viewers and all of our Starlink customers using our beta service at this time. If you're interested in being a part of our beta program, head over to starlink.com and sign up. Hope you enjoyed the webcast today, and we'll see you soon.